Something happened on October 29th, 2025 that shouldn't be possible according to every law of physics we understand. At 6:14 a.m. Universal Time, while most of the world slept, solar observatories across 3 continents recorded an event that would fundamentally alter humanity's place in the universe. The interstellar object we'd been tracking for months, the one scientist had named 3I Atlas, did something no natural object has ever done in the history of astronomical observation. It stopped. Not gradually. Not over weeks or months, as friction with some invisible medium slowly bled away its velocity. In 4 hours, during its closest approach to the sun, this object that had been screaming through our solar system at 47 kilometers per second somehow shed 18 kilometers per second of velocity, executed a 90-degree plane change, and settled into an orbit precisely matching Earth's path around the sun. The maneuver was so precise, so controlled, so utterly impossible for anything natural, that the first dozen observatories to detect it assumed their instruments had failed. The Soho Solar Observatory caught it first. Dr. Helena Voss, a technician at the European Space Operations Center in Darmstadt, Germany, was working the night shift reviewing coronagraph data when she noticed the positional discrepancy. The object wasn't where the predictive models said it should be. At first, she thought she was looking at yesterday's data loaded into today's timestamp, a software glitch that happened occasionally. She closed the program and reopened it. The anomaly remained. She ran the calibration check twice, looking for instrument drift. The calibration came back perfect. Then she pulled up the Stereo A satellite feed from NASA, an independent system watching the same region of space from a different angle. Same anomaly. Different instruments, different positions, identical impossible result. Her hands were shaking when she initiated Protocol Sigma at 6:32 a.m., an emergency notification system that hadn't been activated in 15 years of solar observation operations. Within 8 minutes, her supervisor was on a video call. Within 20 minutes, the European Space Agency's Director of Science was conferring with NASA's Heliophysics Division Chief. Within 40 minutes, observatories on 4 continents were redirecting their instruments toward the coordinates, abandoning scheduled observations of solar flares and coronal mass ejections to focus on this single object that was breaking the laws of motion. The Atacama Large Millimeter Array in Chile swung its 66 radio dishes toward the target. NASA's Solar Dynamics Observatory in geosynchronous orbit confirmed the velocity measurements and sent an automated alert to the Jet Propulsion Laboratory. Japan's Hinode satellite added its data to the growing collection of impossibility. India's Aditya L1 solar mission redirected sensors. China's Advanced Space-Based Solar Observatory joined the unavoidable observation campaign. Every single facility, using different technologies and different methodologies, reported the same result. The object that should have been accelerating as it fell deeper into the sun's gravitational well was instead decelerating at a rate that required propulsion technology beyond anything humanity had ever developed or even seriously theorized. The numbers told a story that made experienced astrophysicists question their sanity. To shed 18 kilometers per second of velocity in 4 hours requires energy. Enormous, almost incomprehensible amounts of energy. Dr. Robert Kim at NASA's Goddard Space Flight Center ran the calculations 3 times, certain he'd made an error. He hadn't. The energy required was 21 x 1021 joules. To put that in perspective, that's the explosive equivalent of 500,000 Hiroshima-sized nuclear weapons detonated simultaneously, and there was no exhaust plume, no thermal bloom, no debris field, no radiation signature consistent with any propulsion system in our theoretical framework, let alone our practical experience. Whatever was slowing this object down was doing it without leaving any evidence that such enormous energy was being released. The trajectory data told an even stranger story. At 6:14 a.m. when the event began, 3I Atlas was at 0.39 astronomical units from the sun, experiencing the intense gravitational pull that should have accelerated it to even higher velocities. By 6:45 a.m., its velocity had dropped to 43 kilometers per second, and its trajectory had begun shifting perpendicular to the ecliptic plane, the flat disk in which Earth and the other planets orbit. By 7:30 a.m. came the event that would dominate analysis for months afterward. Every solar observatory detected a brightness surge across all wavelengths simultaneously, from low-frequency radio waves through visible light into ultraviolet and even X-ray frequency. The surge lasted 11 minutes and 17 seconds. Then it faded, and the object continued its impossible rate. By 8 a.m. Universal Time, 3I Atlas had crossed the ecliptic plane at a fifth previous trajectory. Natural objects don't change planes. Comets follow orbital paths determined by gravity and their initial velocity. They don't suddenly decide to move perpendicular. Yet here was an object doing exactly that, visible to dozens of instruments, trajectory shift undeniable and unexplainable by any natural process. By 9:00 a.m., its velocity had decreased to 35 kilometers per second, and it was actively aligning with Earth's orbital plane. By 10:00 a.m., the alignment was complete. The object had rotated its trajectory to match the flat plane of Earth's orbit around the sun, and by 10:14 a.m., exactly 4 hours after the event began, the velocity had stabilized at 29.78 kilometers per second. That number made Dr. Kim drop his coffee cup. 29.78 kilometers per second is Earth's orbital Velocity. Not approximately. Not within a reasonable margin of error. Exactly, to the second decimal place that his instruments could measure. The object was now maintaining position 0.72 astronomical units behind Earth, roughly 108 million kilometers trailing our planet in its annual journey around the Sun. The configuration was instantly recognizable to anyone who'd studied orbital mechanics. This was a stable trailing Lagrange-type position, a 1.1 orbital resonance with Earth. The object would maintain this exact distance and position indefinitely unless it maneuvered again. It wasn't passing through our solar system anymore. It had taken up residence. Mission control rooms don't panic. They're staffed by people trained to handle anomalies, to troubleshoot in real time, to maintain operational composure when satellites fail or data contradicts expectations. These are professionals who've dealt with everything from communication dropouts during Mars landings to solar storms threatening billion-dollar space telescopes. But on October 29th, in facilities from Pasadena to Moscow to Bangalore to Beijing, you could hear the silence that comes when trained professionals encounter something their entire careers never prepared them for. In the European Space Operations Center, Dr. Voss sat staring at her screen for a full minute, watching the object's position marker hold steady in its new orbit. In Building 264 at the Jet Propulsion Laboratory, 3 orbital dynamics specialists stood around a monitor, nobody speaking, just watching the telemetry data update every 30 seconds with the same impossible precision. Objects in space follow predictable paths. They respond to gravity. They obey conservation of momentum and angular momentum. They accelerate when falling toward massive bodies and decelerate when away. They don't execute powered maneuvers unless someone built engines into them and programmed a flight plan. And they certainly don't decelerate during the exact phase of their orbit when gravity should be accelerating strongly. The official statements started appearing around noon. Careful language in them told its own story. NASA's press release, cleared through 3 levels of management and the agency's legal team, noted unexpected trajectory variations under investigation and mentioned ongoing analysis of gravitational interactions with inner solar system bodies. The European Space Agency's statement talked about unusual deceleration requiring comprehensive model trajectory refinement needed for accurate prediction. Russia's Roscosmos mentioned anomalous velocity change warranting further study. China's space agency noted observations continuing to characterize objects. Not one of them used the word that was already spreading through every private communication channel between observatories, the word that appeared in leaked emails, the word that astrophysicists were typing in text, messages to colleagues at other institutions, propulsion. But the public statement everyone would remember, the one that made headlines within hours and would be analyzed frame by frame millions of times, came from Dr. Sarah Chen at the Harvard-Smithsonian Center for Astrophysics. She'd been studying 3I Atlas since its discovery in July, had published 2 papers on its unusual composition, and was recognized as one of the world's leading experts on interstellar objects. Her institution hastily arranged a press conference for 6 p.m. Eastern Time, carried live on every major news network. Dr. Chen, usually composed and confident in front of cameras, looked tired. She'd been awake for nearly 24 hours analyzing data. She made a brief statement summarizing the observations, using careful scientific language about trajectory changes and velocity measurements. Then a reporter from Reuters asked the question everyone was thinking. Dr. Chen, could this object be under intelligent control? The room went silent. Dr. Chen paused for exactly 7 seconds, a pause that would be replayed millions of times in the coming days. Analyzed by body language experts, turned into memes, dissected for hidden meaning. Then she said, natural explanations for the observed trajectory changes are not currently consistent with our understanding of cometary behavior or gravitational dynamics. We are pursuing all avenues of investigation, including scenarios we might previously have considered unlikely. She paused again, choosing her next words with visible care. I think it's important to follow the data wherever it leads, even if that leads to uncomfortable conclusions. It wasn't confirmation, but it wasn't denial, and the world understood exactly what she wasn't quite saying. Social media exploded before she'd finished the press conference. Dr. Atlas stopped trended globally within 30 minutes, accumulating over 10 million posts in the first hour. Amateur astronomers who'd been tracking the object for months pulled up their archived data and started posting comparison images. The October 25th position versus October 29th position. The velocity graphs showing a smooth hyperbolic trajectory suddenly transforming into a circular orbit. The trajectory plots that looked like someone had drawn a line with a ruler after months of following a gentle curve. None of them needed advanced degrees to see what had happened. Something had changed this object's path intentionally, deliberately, with purpose and control. By October 30th morning, the story dominated every news platform on Earth. Network television interrupted regular programming. Newspapers printed special editions. Radio stations brought in astronomy professors for extended interviews. The internet buckled under traffic loads as hundreds of millions of people searched for information simultaneously. And in the markets where uncertainty equals volatility, the reaction was immediate and dramatic. Stock markets opened in chaos. The Tokyo Exchange saw circuit breakers trip twice in the first hour as algorithms struggled to price assets in a world that had fundamentally changed overnight. When New York opened, space industry stocks tripled in value before noon. Lockheed Martin, Northrop Grumman, and Boeing defense divisions surged on speculation about government contracts for tracking and potential response systems. SpaceX's valuation in private markets jumped 40%. Defense contractor shares across every nation surged as governments clearly began reassessing security priorities. Gold prices jumped 40% as fear drove investors toward traditional safety. Silver, platinum, and other precious metals followed. Cryptocurrency markets ironically collapsed. Bitcoin lost 60% of its value in 8 hours. Ethereum crashed 70%. The speculative digital assets that had seemed so revolutionary suddenly seemed absurdly irrelevant in the face of confirmed extraterrestrial presence. The global economy was repricing reality in real time, and that repricing wiped out $3 trillion of paper wealth while creating $2 trillion in other sectors. Money didn't disappear, it just moved, fast and frightened, toward anything that seemed relevant to humanity's new cosmic context. Religious institutions released prepared statements throughout October 30th, though many would later admit those statements had been drafted years earlier as contingency plans during strategic planning sessions. The Vatican's announcement, delivered by Cardinal Alessandro Benedetti from St. Peter's Square, emphasized that God's creation was vast and that the presence of other intelligences didn't diminish humanity's spiritual significance or God's love for Earth. The statement quoted Psalm 19, "The heavens declare the glory of God, and the sky above proclaims his handiwork." Islamic scholars from Al-Azhar University in Cairo pointed to Quranic verses discussing Allah's creation throughout the seven heavens and beyond. Hindu leaders noted that their tradition had always embraced the possibility of life beyond Earth, citing ancient texts describing countless worlds across the cosmos. Some evangelical Christian groups saw confirmation of end times prophecy, noting biblical descriptions of signs in the heavens. Others saw a theological challenge requiring careful interpretation but not fundamental contradiction. Jewish rabbis discussed the implications through the lens of humanity's unique covenant with God. Buddhist teachers noted that the existence of other intelligent beings was consistent with the vast scope of existence described in their traditions. Every major faith tradition found some way to accommodate what was rapidly becoming undeniable reality. But underneath all the public response, in secure conference rooms and encrypted video calls, another conversation was happening. The UN Security Council convened an emergency closed session on October 30th at 2 p.m. New York time. Representatives from every spacefaring nation received classified briefings running hundreds of pages. Military satellite tracking networks shared data that had never been declassified before, showing that several military systems had also detected the October 29th maneuver and had been quietly monitoring 3i Atlas for weeks. Intelligence agencies from the US, Russia, China, UK, France, India, and Israel compared notes for the first time in history, their usual geopolitical rivalries temporarily overridden by something bigger than international competition. And everyone, from UN ambassadors to military generals to space agency directors to intelligence chiefs, asked the same questions. Is it a spacecraft? Is someone or something aboard? What do they want? Why did they stop? Why here? Why now? And most urgently, what do we do? How do we respond? Who speaks for Earth? What if it approaches closer? What if others arrive? What if it's hostile? Nobody had good answers, but everyone understood that humanity had just been thrust onto a stage we didn't know we were auditioning for. The question that dominated November 1st wasn't whether 3i Atlas had used propulsion. The data made that essentially certain. The question was how. Because while humanity has developed several propulsion technologies over the past century, every single one leaves distinctive signatures, and 3i Atlas showed none of them. Chemical rockets, the workhorses of our space program since the 1960s, work by burning fuel and oxidizer to produce hot, expanding gases that blast out of a nozzle at velocities up to 4.5 kilometers per second. The exhaust plume is massive, visible across millions of kilometers in infrared and even optical wavelength. When SpaceX launches a Falcon 9 from Cape Canaveral, people in North Carolina can see the exhaust plume at twilight. When the James Webb Space Telescope traveled to its L2 position, sensitive instruments could track the mid-course correction burns from Earth. During its October 29th maneuver, 3i Atlas should have produced an exhaust plume that would have been unmissable to every solar observatory watch, especially given the enormous energy requirement. The absence of that plume wasn't an oversight in observation. Dr. Jennifer Torres at the National Solar Observatory in New Mexico led a team that searched specifically for any exhaust signature across every wavelength from radio through X-ray. They examined infrared data that should have shown thermal emission from hot gas. They analyzed ultraviolet data that would reveal ionized particles. They scrutinized visible light images for any dust or debris. They checked X-ray frequencies for high-energy particles. Nothing. No exhaust plume, no gas cloud, no debris field, no thermal signature consistent with combustion. It was as if someone had pushed an enormous object through space without pushing anything backward to create the forward force. Nuclear. Thermal rockets, theoretically more efficient than chemical systems, superheat propellant using a nuclear reactor and expel it at velocities up to 9 kilometers per second. They produce less visible exhaust than chemical systems, but create a distinctive thermal signature in infrared wavelengths and leave traces of radioactive particles in their wake. NASA designed several nuclear thermal rocket concepts in the 1960s and 1970s during Project Nerva. though none ever flew. But the physics are well understood. Nuclear reactions produce heat, heat expands propellant, propellant exits at high velocity. The thermal signature alone would be impossible to miss. Satellites equipped with radiation detectors, including several military early warning systems designed to detect nuclear weapons tests, saw nothing unusual during the October 29th maneuver. No gamma rays, no neutron flux, no radioactive particle traces. Nuclear pulse propulsion, the concept popularized by Project Orion in the 1950s, involves detonating nuclear weapons behind a spacecraft and riding the shockwave forward. It's brutal, inefficient by modern standards, but theoretically capable of achieving high velocities. Each nuclear detonation would produce a flash of radiation detectable from astronomical distances. The October 29th maneuver would have required hundreds of nuclear detonations to produce the observed velocity change. Every radiation detector on Earth and in orbit would have registered the events. None did, and that's before considering that nuclear explosions in space produce distinctive electromagnetic pulses that would have disrupted communications and electronics across the solar system. Nothing was disrupted. Ion drives, which accelerate charged particles to extremely high velocities using electric field, produce low thrust but can operate continuously for months or years. They're efficient, elegant, and currently used on several deep space missions like Dawn and Bepi Colombo. They produce a faint but detectable plasma trail, typically glowing blue from xenon ions, and generate electromagnetic signatures across specific frequencies as the ionization process emits photon. Multiple radio telescopes search the object's position during and after the maneuver, looking for the characteristic emission lines that ion drives produce. The electromagnetic spectrum showed activity, but not the pattern consistent with ion propulsion. The signals were wrong, coming at frequencies that didn't match any known thruster technology, appearing in brief bursts rather than continuous operation, and showing spectral characteristics that didn't correspond to any propellant he had ever. Solar's photon pressure from sunlight for propulsion can work effectively in theory and have been demonstrated on small scales with missions like Icaros and LightSail 2, but they have fundamental limitations. Near the sun, radiation pressure pushes away from the star, not toward it. A solar sail can't decelerate an object approaching the sun. It would accelerate it faster, and no solar sail had been observed deploying from 3I Atlas during its approach. Optical telescopes had been watching it for months, and a sail large enough to produce the observed deceleration, millions of square meters in area, would have been impossible to miss. The radar returns would have been distinctive. The light reflection would have been obvious. None of these signatures appeared. Magnetic sails, theoretical systems that interact with the solar wind and the sun's magnetic field, could potentially slow an object down by creating drag against the charged particle stream flowing from the sun. The concept is elegant, requiring no propellant, but the physics are challenging. They require deployment of enormous superconducting coils, produce measurable effects on the surrounding plasma environment, and work gradually over weeks or months. The October 29th maneuver happened in 4 hours, and spacecraft monitoring the sun's magnetic environment, including NASA's Parker Solar Probe, which was relatively nearby, detected no magnetic field perturbations, no plasma wake, no interaction signatures that would indicate magnetic braking. The solar wind continued flowing past 3I Atlas's position as if nothing was there. Dr. Kenji Yamamoto at JAXA's Institute of Space and Astronautical Science spent November 2nd and 3rd calculating the energy requirements from first principles, using nothing but basic physics and the observed velocity change. The object's estimated mass, based on its gravitational interactions with the solar system measured during its approach, was approximately 2.4 trillion kilograms. The uncertainty range was large, between 1.8 and 3.2 trillion kilograms, but even the lower bound was enormous. To change that mass's velocity by 18 kilometers per second requires kinetic energy equivalent to 500,000 Hiroshima bombs. Released over 4 hours, that's an average power output of 145 terawatts. To put that in context, total human civilization generates about 20 terawatts of power continuously. 3I Atlas generated 7 times total human power output, sustained for 4 hours, and did it without any visible exhaust, thermal bloom, or particle emission. Yamamoto's paper, posted to Archive on November 4th, included a sobering conclusion. The energy release required for the observed maneuver exceeds any propulsion technology currently available to humanity by multiple orders of magnitude. More significantly, the absence of expected thermal, electromagnetic, and particle signatures suggests either physics we do not understand, or technology so advanced that its operating principles are not evident in our observational data. The frame-by-frame analysis of the October 29th maneuver revealed other troubling details. The object didn't just slow down and change trajectory, it did so while maintaining structural integrity under G-forces that should have torn any natural object apart. The acceleration profile, calculated from the velocity measurements taken at 5-minute intervals, showed peaks of approximately 0.3 G sustained for over an hour. That doesn't sound like much compared to rocket launches, which subject payloads to several Gs during ascent, but 3I Atlas is between 220 meters and 2.8 kilometers in diameter, depending on albedo assumptions, at least 10 times larger than the International Space Station. At that scale, even modest acceleration creates enormous tidal stresses across the structure. The front of the object experiences slightly different acceleration than the back, creating internal tension that tries to stretch or compress the structure. A natural comet, which is essentially a dirty snowball of ice and rock loosely bound by weak gravity, would fragment under those stresses like a sandcastle hit by a wave. We've watched comets break apart from far gentler forces. Comet Shoemaker-Levy 9 broke into over 20 pieces just from Jupiter's tidal forces during a close flyby, well before impact. Comet Linear fragmented in 2000 from thermal stresses alone. Comet Ison broke apart during its 2013 perihelion passage, unable to withstand the gravitational and thermal stresses near the Sun. Yet 3I Atlas executed a powered maneuver, generating significant structural stress, did it during perihelion when thermal stresses were at maximum, and remained completely intact. No fragmentation, no debris, no dust cloud, no chunks breaking off. The post-maneuver observation showed the same brightness, the same radar profile, the same spectroscopic signature. Whatever this object was made of, it had structural integrity far exceeding any natural comet. The brightness surge at 7:30 a.m. on October 29th became a focal point for intensive analysis. Dr. Aisha Okonkwo at the South African Astronomical Observatory led an international team that analyzed the event across 17 different wavelengths simultaneously, combining data from ground-based observatories, solar telescopes, and multiple spacecraft. Their November 3rd paper, posted to Archive and submitted to Nature Astronomy, described what they found. The emission spectrum during the 11-minute 17-second event is inconsistent with any known thermal, fluorescent, or reflective process in cometary science. The energy distribution peaks in the blue-green visible spectrum at approximately 480 nanometers, with secondary peaks in near-infrared at 1.2 microns and microwave band 0.4 gigahertz. This distribution doesn't match blackbody radiation at any temperature. It doesn't match solar fluorescence exciting cometary gases, which produce distinctive emission lines. It doesn't match reflected sunlight, which would show the sun's absorption spectrum. Spectral signature appears to be directed energy emission, possibly from an onboard power source or propulsion system during its active phase. The implications of that analysis were clear to anyone who read the technical paper carefully. Blackbody radiation, the thermal glow from heated objects, follows specific mathematical laws described by Planck's equation. The spectrum from 3I Atlas didn't follow those laws. Fluorescence, where molecules absorb photons and re-emit them at different wavelengths, produces distinctive sharp emission lines at specific wavelengths determined by quantum mechanics. The spectrum from 3I Atlas showed broad spectrum emission with unusual peaks. Reflected sunlight carries the sun's spectral fingerprint, including distinctive absorption lines from elements in the solar atmosphere. The spectrum from 3I Atlas was different. It was emission, not reflection. It was broad spectrum, not narrow lines. It was controlled energy release, not passive thermal radiation. Directed energy emission meant control. It meant technology. It meant purpose. But perhaps the most compelling evidence, the piece that made skeptics pause and reconsider their positions, came from the trajectory analysis itself. Dr. Lisa Rodriguez at Caltech's Jet Propulsion Laboratory, one of the world's leading experts in orbital mechanics and interplanetary trajectory design, ran backwards integration of the orbital path on November 5th. Using sophisticated numerical integration software that accounts for gravitational effects from the Sun, all 8 planets, and even major asteroids, she traced where 3I Atlas had come from before entering our solar system. The interstellar approach vector pointed toward a region of space in Sagittarius, unremarkable except for one detail that made her stop breathing when she saw it. The trajectory originated within 9 degrees of the position that produced the famous wow signal in 1977. She ran the calculation again, checking for errors. Same result. She used different software with different algorithms. Same result. She asked 2 colleagues to independently verify the trajectory. Both confirmed it. 9 degrees. Out of the 41,253 square degrees covering the entire sky, 3I Atlas arrived from within 9 degrees of the most famous potential extraterrestrial signal in human history. The WOW signal remains the strongest candidate for an extraterrestrial radio transmission ever detected. On August 15, 1977, the Big Ear Radio Telescope at Ohio State University recorded a 72-second narrowband radio signal at 1420 MHz. The hydrogen line frequency that SETI researchers had long predicted would be ideal for interstellar communication, naturally significant frequency determined by quantum mechanics. Same everywhere. The signal was so strong, 30 times louder than the back, clearly showing exactly the foot call that the astronomer reviewing day, Jerry Amen, wrote, "Wow!" Despite extensive searches, it never repeated. The Big Ear telescope looked at that same region of space dozens of times afterward. Nothing. Other telescopes searched. Nothing. For 48 years, it remained a tantalizing mystery. Rodriguez's paper, posted to Archive on November 6th, laid out the mathematics and the implications. If an object launched from the WOW signal source region in 1977, traveling at 0.1 c, or 10% of light speed, it would reach our solar system in approximately 48 years, accounting for the roughly 480 light-year distance to that region of space. The math worked. The timing was perfect. The trajectory was perfect. She included a speculative section, carefully labeled as such, outlining the hypothesis, They heard our radio broadcasts from the 1920s through 1940s, the earliest powerful transmissions from Earth, reaching their star system around 100 light-years away in the 2020s, 2040s their time. They decided to investigate. They built and launched a probe. They announced its departure with a powerful radio pulse we detected as the WOW signal. And now, 48 years later, their probe had arrived, executed a braking maneuver at perihelion, and taken up position in Earth's orbital plane to study us up close. The alternative was coincidence, that out of the 41,253 square degrees covering the entire celestial sphere, this object happened to arrive from within 9 degrees of the one location that had produced the most famous potential extraterrestrial signal in human history. The probability calculations put that coincidence at 1.7%. Possible, but requiring belief in remarkable bad luck, or, depending on your perspective, good luck. By November 7th, 9 days after the maneuver, the scientific consensus had solidified in private, even as public statements remained carefully worded and cautious. In university departments, in observatory break rooms, in encrypted message groups connecting researchers across continents, the conclusion was the same. 3i Atlas was artificial. It was a spacecraft. Someone had built it, programmed it, sent it across interstellar distances to our solar system, and watched it execute a precision orbital insertion maneuver. And now it was here, holding position 0.72 astronomical units behind Earth, watching us with whatever sensors it possessed, while humanity watched back through every telescope we could point at it and wondered what came next. The United Nations building in New York had seen its share of crises, wars, famines, nuclear standoffs, pandemic, but on October 31st, when the Security Council convened its emergency closed session on 3i Atlas, something was different. The usual geopolitical posturing, the carefully prepared statements designed to advance national interests while appearing cooperative, the diplomatic dance that typically characterized these meetings, all of it evaporated in the face of something that rendered national borders suddenly quaint. Ambassador Chen Wei from China sat next to Ambassador James Morrison from the United States, and for the first time in their 3-year working relationship, they weren't adversaries calculating advantage. They were two humans trying to figure out how humanity should respond to visitors. The problem became apparent within the first hour. Nobody had planned for this. The UN Office for Outer Space Affairs, established in 1958, had protocols for Earth-launched satellites, space debris, planetary protection, and even asteroid impact scenarios. But those protocols assumed human actors making decisions about human technology. SETI, the Search for Extraterrestrial Intelligence, had developed post-detection protocols in the 1980s, refined over decades by committees of scientists and diplomats. But those protocols assumed radio signals from light years away, giving humanity years or decades to craft responses and build consensus. They assumed first contact would happen at interstellar distances, mediated by the speed of light, with plenty of time for careful deliberation. 3i Atlas was already here. It was 108 million kilometers away, close enough that light travel time was 6 minutes. Close enough that if it decided to approach Earth directly, traveling at the velocities it had already demonstrated, it could be in lunar orbit within weeks. The SETI protocols assumed we'd detect a signal, verify it over months or years, debate response messages, and eventually transmit something carefully crafted to represent humanity. None of that applied when the source of the signal was a physical object in our orbital neighborhood that had just demonstrated technological capabilities exceeding our own. The fundamental question paralyzed decision-making. Who speaks for Earth? The United Nations, by charter, represented member nations, not humanity as a unified entity. The Security Council's 5 permanent members, China, France, Russia, the United Kingdom, and the United States, claimed authority through historical accident and nuclear arsenals, not through any legitimate claim to represent human civilization. The scientific community, represented by institutions like the International Astronomical Union, had expertise but no political authority. Religious leaders represented billions of followers but had no diplomatic standing, and everyone knew that whatever message humanity sent, if any message was sent, would be scrutinized by future historians as the moment we introduced ourselves to cosmic civilization. By November 2nd, the UN had announced formation of the Contact Response Committee, a compromise structure that satisfied no one but prevented complete paralysis. 15 nations, 30 scientists, representatives from major religious traditions, and observers from various international organizations. Their mandate was deliberately vague: coordinate international response to the 3i Atlas situation and advise on communication protocols if appropriate. The committee's first meeting, held via secure video conference on November 3rd, lasted 11 hours and accomplished almost nothing except establishing subcommittees. Meanwhile, the implications were cascading through every system of human civilization. Dr. Thomas Ashford, an economist at the London School of Economics, published a rapid assessment on November 4th examining the economic disruptions. The repricing of reality, he called it. Insurance companies were recalculating risk models for everything from life insurance to satellite coverage, trying to factor in the non-zero probability of contact, conflict, or technological disruption from extraterrestrial sources. Defense budgets were being hastily revised as governments realized their military spending assumptions were obsolete. Space industry venture capital, which had been growing steadily, exploded by 800% in the first week of November as investors bet on technologies for detection, communication, or defensive purposes. But the deeper disruption was psychological. Dr. Yuki Tanaka, a sociologist psychologist at Tokyo University, conducted rapid response surveys across 15 countries between November 1st and 5th, trying to measure how quickly collective human consciousness was adapting. The results surprised her. Panic was minimal, far less than she'd expected. Acceptance was high, especially among younger demographics who'd grown up consuming science fiction and seemed almost prepared for this moment. But there was a profound sense of deflation in one metric. Humanity's self-assessed importance in the cosmos dropped from 7.2 to 3.1 on a 10-point scale. "We went from thinking we might be special," one survey respondent wrote, "to knowing we're probably not." Religious responses varied more than the secular responses. On November 3rd, Pope Francis gave an unexpected address from the Vatican, not the prepared statement that had been released days earlier. "God's creation is more magnificent than we imagined," he said, speaking without notes. "If our brothers and sisters from distant stars have come to visit us, then we must greet them with the love Christ commanded. We must show them the best of humanity, not the worst. We must remember that all creation serves the glory of God, and we are part of that creation, not its center." The address was simultaneously humble and hopeful, and within the Catholic community, it largely settled the theological questions. Islamic scholars gathered in Cairo on November 5th for an emergency conference. The conclusions published that evening emphasized Quranic verses discussing Allah's creation of multiple worlds and the vastness of divine power. "If Allah has created intelligent beings beyond Earth," the statement read, "then this confirms what the Quran has always told us, that creation extends throughout the heavens, and that Allah's knowledge and power are beyond human comprehension." The statement was endorsed by senior scholars from both Sunni and Shia traditions. Hindu leaders noted that their cosmology had always included countless worlds and forms of life. Buddhist teachers focused on the implications for consciousness and suffering, asking whether extraterrestrial intelligence experienced the same cycle of attachment and suffering that characterized human existence. Jewish rabbis debated whether the covenant with God was Earth-specific or applied more broadly. Evangelical Christian communities were the most divided, with some seeing fulfillment of apocalyptic prophecy and others seeing a theological challenge requiring careful reinterpretation of Scripture. But underneath all the institutional response, individual humans were processing the revelation in deeply personal ways. Mental health hotlines reported sustained elevated call volumes through early November. The calls weren't panic mostly. They were existential. "I don't know what my life means anymore," was a common theme. "Everything I thought was important seems small now." Therapists and counselors found themselves navigating territory without precedents or guidelines. How do you help someone process the realization that humanity isn't alone when you're processing the same realization yourself? Dr. Elena Volkov, a psychologist at Moscow State University who specialized in crisis response, published preliminary observations on November 6th. "We're witnessing the most rapid collective psychological adaptation in human history," she wrote. "Every person on Earth is simultaneously processing the same revolutionary information. The shared experience is creating unexpected solidarity. People report feeling more connected to other humans, more aware of our common humanity, precisely because we're now aware of non-human intelligence. The us versus them dynamic that characterizes so much human conflict is shifting. Suddenly, us means all of humanity." The detection rate question haunted astronomers. 3 interstellar objects in 8 years, when models predicted 1 per decade. Dr. Marcus Webb at MIT ran simulations through November 2nd and 3rd, trying to understand what the increased rate meant. If the detections were random, if interstellar objects were simply more common than models predicted, then the galaxy contained trillions of such objects wandering between stars. That was possible, even likely. Most star systems probably ejected rocky and icy bodies during formation, and those bodies could wander indefinitely. But if the detections weren't random, if there was clustering or intentional targeting, then the implications shifted dramatically. Webb outlined 3 scenarios in a paper posted November 4th. First, statistical fluke. We got lucky or unlucky depending on perspective, and the rate would normalize over time. Second, observational bias. Our detection capabilities had improved significantly, and we were simply finding objects that had always been passing through but went unnoticed. Third, and this was the scenario that kept him awake at night, intentional visitation. If even one of the 3 objects was artificial, and if there was any coordination or planning involved, then Earth was receiving attention from sources unknown. The progression was suggestive. 2017, Oumuamua tumbles through. Cigar-shaped or pancake flat, depending on interpretation, exhibits non-gravitational acceleration that doesn't match comet outgassing. Natural or artificial remains debated. 2019, 2I Borisov appears, looks completely natural, behaves like a standard comet from another star system. It serves as a control, showing what a normal interstellar comet looks like. 2025, 3I Atlas arrives with extreme anomalies, executes powered maneuver, takes up residence in Earth's orbital plane. If you were conducting reconnaissance, Webb noted, you might send multiple probes. First, a fast flyby to gather initial data. Second, a natural appearing object to compare with local bodies and avoid drawing attention. Third, an advanced platform capable of station keeping for extended observation. It was speculation, careful to label itself as such, but the pattern was hard to ignore. Dr. Sarah Chen, whose press conference had catalyzed global awareness, published a personal essay on November 7th that captured the scientific community's internal struggle. "We're trained to be skeptical," she wrote, "to demand extraordinary evidence for extraordinary claims. to exhaust natural explanations before considering exotic ones. But at some point, when natural explanations require increasingly elaborate special pleading, when coincidences pile up beyond statistical credibility, when the simplest explanation is the one we're trained to resist, we have to ask whether our training is serving truth or protecting comfort. The data from 3i Atlas points toward artificial origin with high confidence, not certainty. High confidence, and we need to be honest about that, even as we continue investigating. By the end of the first week of November, humanity had fractured into roughly 3 camps. The first, perhaps 30%, based on polling data, believed 3i Atlas was definitely artificial and likely carried implications for contact. The second, about 50%, thought it was probably artificial but wanted more evidence and remained uncertain about intentions or next steps. The third, around 20%, still believed natural explanations would eventually emerge and that humanity was jumping to conclusions from limited data. But almost everyone agreed on one thing. We were living through a historical pivot point. Whether 3i Atlas turned out to be natural or artificial, whether it approached closer or eventually left, whether others arrived or this remained singular, October 29th, 2025 had marked a boundary. Before that date, we wondered. After it, we knew at least this much. We weren't alone in the universe, and the universe had noticed us enough to stop by. November 1st marked the beginning of the most intensive astronomical observation campaign in human history. Every major telescope on Earth and in orbit redirected toward a single target. The Hubble Space Telescope, aging but still capable, cleared its observation schedule. The James Webb Space Telescope at the L2 Lagrange point, primarily designed for infrared observation of the early universe, turned its massive mirror toward 3i Atlas. Ground-based observatories from Hawaii to Chile to South Africa coordinated observations to maintain 24-hour coverage as Earth rotated. Amateur astronomers joined the effort, their smaller telescopes providing temporal coverage that no single professional facility could match. Dr. Rebecca Stone at the Space Telescope Science Institute coordinated the Hubble observation. On November 1st, during the first dedicated observation window, Hubble captured images at 0.05 arcsecond resolution, the sharpest views of 3i Atlas yet obtained. The object appeared as an elongated blur. Brightness concentrated toward one end, fainter extensions on the other. It wasn't a perfect sphere or cylinder. The shape suggested complexity, possibly modular construction. Stone's team processed the images for 48 hours, using every enhancement technique available. By November 3rd, they released preliminary finding. The object shows geometric regularities inconsistent with natural formation. Surface features suggest paneling or segmentation rather than random impact cratering. Radio telescopes joined the campaign immediately. The Very Large Array in New Mexico, the ALMA Array in Chile, the 500-meter aperture spherical telescope in China, and dozens of smaller facilities swept every frequency from megahertz to terahertz ranges. They searched for any emission, any signal, any electromagnetic activity beyond reflected sunlight. Dr. Marcus Webb coordinated the radio observations through a hastily assembled international. The data from November 1st and 2nd showed background noise, cosmic radio sources, but nothing distinctive from 3i Atlas itself. Then November 3rd happened. At 2:17 a.m. Universal Time, radio telescopes detected a narrow band emission at 1420. The hydro frequency SETI researchers had predicted for decades for interstellar communication, determined by quantum mechanics. The same everywhere, and the emission lasted exactly 47 seconds. Its intensity was modest, barely above background, but its frequency was precise to 9 decimal places. Natural astronomical sources don't produce narrow band emissions, they produce broad spectrum noise. This was a signal. Dr. Aisha Okonkwo was on duty at the South African Radio Observatory when the detection occurred. She watched the spectrogram in real time, the distinctive spike appearing exactly at 1420 megahertz, holding steady for 47 seconds, then disappearing immediately. Initiated verification protocols, checking for local interference, satellite transmissions, terrestrial sources. Nothing matched. She contacted the ALMA Array in Chile. They detected it too. Within 30 minutes, 5 independent facilities confirmed the emission. It was real, and it came from 3i Atlas. The signal structure was elegant. 3 pulses during the 47-second window, spaced 1.1 seconds apart, with intensity ratios of 1.2.3. Sequential integers. The mathematical simplicity was deliberate. Natural processes don't count in integers. This was a message, even if the content was simply, we can produce coherent signals in patterns you'll recognize as non-natural. November 4th at 2:17 a.m. UTC, the event repeated. Identical 47-second duration, same 1420 megahertz frequency, but the pulse pattern changed, 135.7, odd numbered. Again, mathematical sequence, but different. Progression, variation, demonstrating intent. Every major radio telescope was watching this time, alerted by the previous night's detection. The coordination was clear. 3i Atlas was signaling at a specific time with specific patterns, showing capability and intelligence. November 5th brought another. The event occurred at 2:17 a.m. UTC again, but the pulse pattern was 115. The Fibonacci, where each number is the sum of the. Dr. Chen recognized it immediately when she saw the data. It's demonstrating mathematical knowledge, she told the observation working group during an emergency call, showing us it understands number theory, sequences, the mathematical structures we'd recognize as universal. November 6th, observers worldwide watched their instruments at 2:17 a.m., anticipating the signal. It came at 2:16:13 a.m. instead, 47 seconds earlier than expected. The pulse pattern was prime numbered 2.35.7 pointed 11. The timing shift was the key. Not random variation, but systematic advance 47 seconds earlier. The signal was evolving, changing both content and timing, showing control over both what it transmitted and when. By November 7th, the pattern was clear. The signal came 47 seconds earlier each night, and the mathematical patterns progressed in complexity. That morning's signal showed square numbers 1.491625. Dr. Yuki Tanaka at Tokyo University compiled the progression and posted analysis. The pattern demonstrates 1. Technological capability to generate precise, narrow-band emission. 2. Mathematical knowledge across multiple domains. 3. Awareness of timing and the ability to control it precisely. 4. Intentional communication designed to be recognized as artificial. 5. Progression suggesting ongoing attention and response to our observation. The communication attempts from Earth had begun November 1st, even before 3i Atlas started its signal. The Arecibo successor facility, a 300-meter dish in Puerto Rico, transmitted the first deliberate methodology. 8 Gual RPM UTC. The content was carefully crafted by an international committee. Prime numbers from 1 to 100, mathematical constants like pi and e, the periodic table of elements, binary counting systems, and a simple diagram of the solar system with Earth's position marked. The transmission used the 2.4 GHz frequency, chosen because it's within the water hole, a quiet region of the electromagnetic spectrum between hydrogen and hydroxyl emission lines, where SETI researchers expected artificial signals would be sent to minimize background noise. No immediate response came. The signal took 6 minutes to reach 3i Atlas at its current distance. Any response would take another 6 minutes to return. The transmission team waited 30 minutes, watching for any reaction. Nothing. November 2nd brought more attempts. Goldstone Deep Space Communications Complex in California joined the effort. So did the Green Bank Telescope in West Virginia. Multiple facilities transmitting at different frequencies, using different encoding schemes, all carrying variations of the same basic message. We are here. We see you. We want to communicate. When 3i Atlas began its own signals on November 3rd, the question became, was it responding? The timing suggested awareness. Earth had been transmitting for 2 days. The object began signaling on the third day, but it wasn't responding to our transmissions directly. It wasn't echoing our messages or using our frequencies except for that first 1420 MHz signal. It was conducting its own demonstration, showing capability on its terms, at its chosen times. Dr. Malcolm Foster, a communication theorist at Oxford, published rapid analysis on November 5th. The pattern suggests intentional teaching, he wrote, like an adult showing a child how to count. Start simple, integers, progress to basic concepts, odd numbers, advance to universal mathematics, Fibonacci, demonstrate sophistication, primes, show control, timing variations. The entity or entities aboard 3i Atlas are establishing common ground, demonstrating intelligence in ways we can recognize, building towards something more complex. Radar observations provided crucial data about the object's physical structure. The Arecibo successor transmitted radar pulses at 2.38 GHz on November 4th and 5th, and sensitive receivers detected the echoes returning 6 minutes later. The radar return strength and timing revealed information about size, shape, surface properties, and rotation. Dr. Jennifer Torres led the analysis team, working around the clock to process the data. The results published November 6th were startling. The radar cross-section suggests an object approximately 2.1 kilometers in longest dimension, 800 meters in shortest, with high confidence. The surface is remarkably smooth for a natural object, showing radar reflectivity consistent with metallic or metallic composite materials in some regions, carbon composite materials in others. The echo timing shows no significant variation over multiple radar passes, indicating either very slow rotation or active 3-axis stabilization. Natural objects tumble. This object maintains fixed orientation. Thermal imaging from infrared satellites added another piece. NASA's Wide Field Infrared Survey Explorer, normally used for asteroid detection, mapped 3i Atlas's thermal profile on November 3rd and 4th. The temperature distribution didn't match solar heating patterns. Objects in space get hot on the sun-facing side and cold on the shadow side. 3i Atlas showed hotspots that didn't correlate with sun exposure, suggesting internal heat sources. The temperature variations indicated active thermal management, like a spacecraft radiating waste heat from power systems or life support. Spectroscopic analysis continued from ground-based observatories. The surface composition, measured by analyzing reflected sunlight, showed that layered structure previously identified as radiation-processed organics. But high-resolution spectroscopy revealed something new. The layers were too uniform. Natural radiation processing over billions of years creates gradients, variations in depth and composition as cosmic rays penetrate to different depths in different locations. The crust on 3i Atlas was uniform to within 5% across all measured locations. That uniformity suggested engineering, deliberate construction of a multi-layer thermal protection system. Amateur astronomers made unexpected contributions. Qichang Zhang, observing from Taiwan with a 12-inch telescope, noticed brightness variations on November 5th that suggested rotation or attitude changes. He posted his light curve data to online forums, and within hours, other amateurs confirmed the pattern. The object was rotating, but the period was exactly 24 hours. Exactly. Not 23.9 hours or 24.1 hours. 24 hours synchronized with Earth's rotation. Dr. Stone called it the detail that makes skepticism untenable. Natural objects don't rotate with periods matching the planet they're observing. That's intentional synchronization. By November 7th, 9 days after the October 29th maneuver, the accumulated evidence painted a consistent picture. 3I Atlas was artificial. It possessed active propulsion capable of enormous delta-v changes. It maintained precise orbital position through station-keeping maneuvers. It generated narrow-band radio signals at mathematically significant frequencies and patterns demonstrating intelligence. It maintained fixed orientation rather than tumbling. It showed thermal signatures indicating internal power sources. Its surface exhibited engineered materials and uniform layering, and it rotated with a period synchronized to Earth's rotation. Dr. Sarah Chen compiled the findings into a comprehensive assessment posted November 7th evening. The probability of all observed characteristics occurring in a natural object is effectively zero. We are observing an artificial spacecraft of non-human origin. It appears to be conducting observation of Earth. Its signals suggest awareness of our presence and attempt to establish communication framework. The question is no longer whether it's artificial. The question is, what happens next? Humanity watched, measured, and waited for the answer. November 7th, 2025. 9 days since everything changed. 9 days since an object from another star system executed a maneuver that shouldn't exist and took up residence in our orbital neighborhood. 9 days since humanity learned, definitively, that we're not alone. The morning sky over Tokyo shows 3I Atlas as a faint point of light low on the eastern horizon, visible for about 40 minutes before dawn, brightens the sky too much. Amateur astronomer Hiroshi Matsuda stands in his backyard with a 6-inch telescope, the same instrument he's used for 30 years to observe planets and comets. But this morning, like every morning since November 1st, he's pointed at coordinates that contain something unprecedented. He can see it in his eyepiece, a tiny blur that doesn't look remarkable at all. Just another faint smudge among millions of celestial objects. Except this one stopped. This one chose to be here. I keep thinking about the distance, Matsuda later tells a reporter. That light I'm seeing left the object 6 minutes ago. 6 minutes. I could have a conversation with someone on the other side of Earth, faster than light could travel between me and whatever built that thing. It's right here. It's in our neighborhood. And I don't know if that's wonderful or terrifying. Across the globe in Sao Paulo, Maria Santos checks her phone for the 100th time today, refreshing the live data feed from the Contact Response Committee. She's not a scientist, not an astronomer, just a high school history teacher trying to understand how to teach her students about a present that's becoming history faster than textbooks can be written. Yesterday, 3 students asked her what happens if 3I Atlas approaches Earth. 2 others asked if we should try to visit it. One asked the question she couldn't answer. Why did it come here? I told them we don't know yet, she explains to her colleague during lunch break, but I also told them this is why we study history. So we can understand that moments like this, moments when everything changes, they've happened before. When Europeans reached the Americas, when we split the atom, when we landed on the moon. Humanity has survived transformative moments before. We adapt, we change, we continue. But privately, she's not entirely sure. Because those previous transformative moments involved humans encountering other humans, or humans encountering nature, or humans encountering their own capabilities. This is different. This is encountering intelligence that traveled between stars, that possesses technology we can't explain, that might operate under assumptions and motivations we can't comprehend. History provides no real precedent for this. At the European Space Operations Center, Dr. Helena Voss has worked double shifts every day since October 29th. Her initial detection of the anomaly has made her unexpectedly famous, interview requests flooding in from media outlets she's never heard of. She ignores most of them. The data is what matters. By November 7th, the accumulated observational data on 3I Atlas fills servers with terabytes of measurements, position over time, velocity vectors, spectroscopic signatures across dozens of wavelengths, radar profiles, thermal maps, radio emissions. Every pixel captured, every photon counted, every signal recorded. The analysis shows what she expected after that first impossible morning. The object is maintaining position with extraordinary precision. After 9 days, 3I Atlas remains at exactly 0.72 astronomical units trailing Earth. The velocity matches Earth's orbital speed to 4 decimal places. That kind of precision requires active control, continuous monitoring, constant tiny corrections to counteract gravitational perturbations. You don't maintain that precision unless you intend to. It's watching us, Voss tells her supervisor during their daily briefing. Not a question. A statement. It came here. It stopped. It positioned itself where it can observe Earth indefinitely, and it's staying. The signals at 2:17 a.m. each morning, those mathematical patterns, that's not random. It's telling us, I'm intelligent, I see you seeing me, I'm here intentionally. Everything about this is purposeful. The Contact Response Committee, meanwhile, has fractured into competing factions by November 7th. The scientists want to continue observation and attempt structured communication. The politicians want control over any messaging to ensure it represents appropriate interests. Though they can't agree whose interests those should be, religious representatives argue that any communication must acknowledge humanity's spiritual nature. Military advisors, present in closed sessions, discuss contingencies that everyone hopes remain theoretical. Dr. Sarah Chen sits in her office at Harvard, watching the committee's public sessions via live stream and feeling frustrated. The bureaucracy, the territorial disputes, the careful diplomatic language designed to offend no one and therefore say nothing meaningful, all of it seems absurdly inadequate to the moment. An intelligence from another star system is in our solar system, demonstrating awareness of our presence, and humanity's response is forming subcommittees. On November 6th evening, she'd written an op-ed for Science magazine that captured her frustration. We stand at a threshold unmatched in human history, and we're responding with the same institutional inertia that characterizes our approach to climate change, pandemic preparedness, and every other challenge requiring coordinated global action. 3I Atlas isn't waiting for us to reach consensus. It's here now. It's signaling now. Every day we spend debating who has authority to respond is a day we waste when we should be learning, listening, attempting to understand what it's trying to tell us. The op-ed went viral within hours, shared millions of times, translated into 40 languages. It resonated because it captured what many people felt. The institutional response seemed inadequate to the magnitude of the moment. The scenarios modeled by various research groups paint a wide range of possible futures. Dr. Marcus Webb at MIT leads a team analyzing the probability distributions. Best case, 3I Atlas continues observation for weeks or months. The mathematical signal patterns gradually evolve into more complex communication. Humanity and the probe establish basic information exchange, and eventually it departs having completed its mission. Likely case, the object maintains its current position indefinitely, signaling periodically but not escalating to complex communication. Concerning case, additional objects arrive, and Earth becomes a cosmic crossroads with multiple intelligences converging on our location. Challenging case, the object begins approach toward Earth's orbit, entering the Earth-Moon system, triggering potential international crisis. And then there's the scenario Webb doesn't assign probability to because it's incalculable, something we haven't imagined. Technology sufficiently advanced, as Clark noted, is indistinguishable from magic. If 3I Atlas represents capabilities centuries or millennia beyond ours, its actions and motivations might be incomprehensible. But beneath all the analysis and speculation, a transformation is already happening to human civilization. Dr. Elena Volkov in Moscow has conducted follow-up surveys through the first week of November, tracking how quickly human psychology adapts to revolutionary information. The results show unexpected patterns. After the initial shock of October 29th-31st, anxiety levels actually declined. By November 7th, most survey respondents reported feeling curious rather than fearful when thinking about 3I Atlas. More significantly, Volkov's data shows shifting identification patterns. When asked, "Who are you?" responses before October 29th emphasized national, religious, or ethnic identity. Responses after November 1st increasingly emphasized human identity. "I'm human" became a more common self-description than "I'm American," or "I'm Christian," or "I'm Chinese." The presence of non-human intelligence was creating, paradoxically, stronger human solidarity. The tribal instincts that drove so much conflict throughout history were being redirected. Suddenly, us versus them meant humanity versus cosmic civilization. And within that framework, human differences seemed smaller. Educational systems were transforming rapidly. Universities reported astronomy enrollments up 600% for spring semester registration. Philosophy departments saw similar surges. Astrobiology, previously a niche field, became the most popular declared major at 17 universities. Students ask different questions now. Not just what do I want to be, but what should humanity become in a universe with neighbors? The economic adaptation continued. By November 7th, markets had largely stabilized at new equilibrium points. Space industry stocks remained elevated. More interesting were the sectors showing unexpected growth. Linguistics and translation technologies surged as companies bet on potential need for decoding alien communication. Material science companies focused on exotic alloys attracted massive investment. Energy sector focus shifted dramatically toward exotic propulsion research. Religious institutions continued adapting theology in real time. The Vatican announced on November 6 that Pope Francis would deliver a major encyclical addressing the theological implications of extraterrestrial intelligence by December. Islamic scholars published preliminary consensus that contact with alien intelligence didn't contradict Quranic teaching. Hindu leaders noted ancient texts describing travelers between worlds. Some evangelical Protestant groups remained convinced 3I Atlas represented end times prophecy fulfillment. Others underwent rapid theological revision, deciding that God's creation was broader than literal biblical interpretation suggested. But perhaps most profound was the shift in how humanity viewed its own future. Before October 29th, space exploration was aspirational, something we might do if we solved Earth's problems and found sufficient motivation and resources. After November 7th, it became existential. The universe wasn't empty. It was populated, active, and we just received proof that interstellar travel was possible because someone had done it. The question shifted from can we explore space to how quickly can we develop the capabilities to participate in whatever larger cosmic civilization exists. Dr. Chen published a second essay on November 7th evening, more hopeful than her first. 9 days ago, we learned we're not alone. That knowledge changes everything. It changes how we see ourselves. It changes what's possible. It changes what's important. We went from being the pinnacle of creation to being participants in something vastly larger. That should be humbling, and it is. But it's also liberating. Every limitation we thought was fundamental, every boundary we thought was absolute, they're all negotiable now. If they can cross between stars, eventually we can too. If they can manipulate energy in ways our physics doesn't explain, eventually we'll understand those principles. The universe just opened up, not as empty void, but as populated space containing others who've solved problems we're still working on. That's not threatening, that's inspiring. As November 7th ends across different time zones, millions of humans go outside after dark to look up. They find the constellation Sagittarius low in the southern sky, knowing that somewhere in that direction, nearly 500 light-years away, is whatever star system launched this probe. They wonder if anyone there is looking back, waiting for their probe's report, curious about what it found orbiting a small yellow star in what we call the Orion Spur. And 108 million kilometers ahead of Earth, in our mutual orbit around the Sun, 3I Atlas continues its vigil. At 2:15:26 a.m. UTC on November 8th, it will transmit again, the mathematical pattern progressing to the next sequence, demonstrating continued awareness and intent. Humanity will listen, record, analyze, and wonder what it means. What comes next? Whether contact will deepen or remain at this careful distance. The cosmic conversation has begun. We didn't start it, but we're part of it now. The future is uncertain. The implications are enormous. The possibilities are infinite. October 29th, 2025 will be remembered as the date everything changed. When humanity learned definitively that we're not alone. When our story became part of a larger narrative we're only beginning to understand. And somewhere in a classroom in Sao Paulo, a teacher will stand before her students tomorrow morning and try to explain what it means to live through a moment when history pivots, when the future becomes unrecognizable. When everything humanity thought was certain becomes negotiable. She'll tell them the truth. We don't know what happens next, but we'll face it together, as humans, finally united by the presence of something beyond ourselves. The object that stopped watches us still, and we watch back. And somewhere between the watching, understanding might begin.